Today we're going to learn about similar figures. Today's foldable notes fold up into I put this pen down, a little booklet like this, a true foldable. So let's get started. Okay, so similar figures are two figures that are the same shape. They just might not be the same size, but similar figures are always the same shape. Their corresponding angles are congruent. Remember that the word congruent in geometry basically means equal. It means same shape and size, and their corresponding sides are proportional. So we're going to be tapping into all that stuff we learned about proportions earlier in the year. So here's an example of two similar figures. So it says the triangle ABC is similar to triangle DEF. This little symbol right here, that little squiggly, that means similar. And it does matter the order that those letters are in, those points are in, because it means that since I don't know why I switched to pen, since point A and point D were named first, that means that angle A and angle D are the same size and they're corresponding in those shapes. And then the second point that they named in the names are B and E. So that means angle B and angle E are corresponding angles in those shapes and they're the same size. And lastly, point C and point F were named in the same spot in those triangle names. So C and F are corresponding and that means they're the same size. So we've already kind of answered this first question here, that angle A is congruent to angle D, and angle B is congruent to angle E, and angle C is congruent to angle F. And the sides that go together can also be found in the name. So what I mean by that is since AB are named together here, then side AB corresponds with DE because AB and DE in both names of the triangles are the first two letters. So then that means, and you can see over in the triangle, I'll also highlight them. If I could go to the highlighter here, AB and DE are corresponding sides. You can see they're not the same size, but they're in the same place. All right, then we have BC, which is right here, and that side corresponds with FE, and you can look up in the name of the triangles to see that those letters are in the same place in the name. And finally, we have that side AC or CA. It doesn't matter which order you put those letters in when you name them. When you say the name of a line segment, you can say CA or AC. It doesn't matter, but it corresponds with side FD or DF. All right, so let's try some examples here. So here's my favorite tip of the day. You know I like colorful things. So if we use highlighters to show the corresponding sides, it makes our life a lot easier. So here's the name right here of my two quadrilaterals. PQRS is similar to HIJK, which means that angle P goes with angle H and angle Q goes with angle I. It also means that side PQ corresponds with side HI because of the order of those letters in the names. So I'm going to highlight the corresponding sides in the same color. So PQ corresponds with HI, and QR corresponds with IJ, SR corresponds with KJ, and lastly, SP corresponds with KH. So now I can just go ahead and answer these questions down here. It says that SP, which is blue, goes with PQ, which is yellow. So KH, which is blue, must go with the yellow in the other shape. SR, which is green, and let me do the one over here. Look at the one that's complete first. So QR is pink and IJ is pink in the other shape. So we have pink over pink. So since SR is green, we need to do green over green. And for this one, HI is yellow and IJ is pink, so we're doing yellow over pink equals yellow over pink. QR is pink and PQ is yellow. And I might even want to go and like highlight those. All right, QR is pink and SP is blue, so we're doing pink over blue equals pink over blue. So the pink in the other shape is IJ. All right, so that's just to show you which sides correspond and how to make a proportion out of them. Now let's put it to work. I think it's actually less confusing to do a problem than it is to kind of show you how they correspond. So here's the first example. ABC is similar to DEF, which means that I can make a proportion with their corresponding sides. I'm going to use a highlighter again. You know I love the highlighters. So this side, AB, corresponds with side DE. I can tell just by looking at those two shapes that they correspond. But if I needed to double check, I would see that those two letters are the first ones in the name. So that is true that they correspond. And then BC and EF correspond. So I could do a proportion like this. I could do blue over pink equals, guess what? Blue over pink. And set it up like that. Remember, a proportion is just two equal fractions. So the big shape has blue 15, yellow 10, and the little shape has blue X and pink 4. So you just can't switch them. You can't do like blue over pink and then switch it to pink over blue. It has to be corresponding sides, and they need to be set up the same way. Once you do that, that's the hard part, setting up the proportion. And it's not even that hard if you use my tip of highlighting. Then you just use cross products to solve. So 10 times x equals 15 times 4. So 10x equals 60. And then since x is being multiplied by 10, the opposite is divide by 10. I find that the missing side is 6. So that means that this side has a length of 6. One more example here. These two trapezoids are similar, and they are written out here. WXYZ is similar to MNPL. And those letters really matter now because those trapezoids are not drawn facing the same way. But I could either redraw one of those trapezoids so they are facing the same way and then relabel them, or I can highlight. I know that WX corresponds with MN because of where they're named in the shape, right? And I know that side XY, which are the middle two letters, correspond with NM and P, because those are the two middle letters in the names. I also know that LP corresponds with YZ. So this actually gave me more information than I needed because the small trapezoid gave me 3 measurements and I only need 2 of them. So in the big trapezoid, I have the 36. I have the blue, so I definitely want to use blue. And then the one I'm looking for is PN, which is yellow. So I want to use the yellow also. So I can do like blue over yellow equals blue over yellow. I'm not using the pink because pink is not one of the sides I was given or one of the sides that I was trying to find in the big trapezoid. So let's do little blue over big blue equals, whoops, I did not say that right. Let's do little blue over little yellow equals big blue over big yellow. We don't know this side. So I'm going to do my cross products of 24x equals 18 times 36. If I do 18 times 36 on my calculator, whoops, sorry about that, I get 648. It just floated away from me. And now it's a one-step equation. So since x is being multiplied by 24, I'm going to divide both sides by 24 to find the missing side is 27. Thanks for watching.